Hello students, let us discuss acidic dehydration of alcohols. What do you mean by dehydration? Hydration would relate to water. Dehydration means removal of water. So what do you mean by acidic dehydration? That means removal of water in the presence of acid. So let us discuss the dehydration in alcohols. Alcohols undergoes dehydration, that is removal of water molecule to form alkene. The product alkene is obtained when we remove the water molecule from alcohol. That process is called as dehydration. This reaction is taking place in the presence of protic acids. Protic acid, example, concentrated H2SO4 or H3PO4. Why it is called as protic acid? Because it gives H plus ion. So in the equation you can write it is written H plus here. What it means? This reaction is taking place in the presence of acid, that is protic acid, which is represented in terms of H plus here. And even the catalyst can also be used like anhydrous zinc chloride or alumina. So let us discuss this equation, how the removal of water takes place from an alcohol to form alkene. Generally, we are representing alcohol in this way, in this 2 carbon atom, and you can see H and OH. It is a molecule general representation. The removal of water, that means OH and H together it forms water. That means the alcoholic group and adjacent carbon atom H together it forms water. There is a removal of water. If this is an alpha carbon, so this carbon will be a beta. So a removal of OH group from alpha carbon and the removal of H from the beta carbon, that result in the formation of water. So here there is a formation of double bond between the alpha carbon and beta carbon, that you can see between the alpha carbon and beta carbon there is a formation of double bond. So that is a dehydration, removal of water. Let us discuss the dehydration in the case of ethanols. Ethanol undergoes dehydration by heating with the concentrated H2SO4 at 443 Kelvin. First, let us write this equation in the expanded form. C2H5OH, it is written in this way, that is CH3CH2OH. We can write this in this way. Ethanol can be written, that is CH3CH2OH. Now when you look at here in this, which one is the alpha carbon? This is the alpha carbon because OH group is attached on this carbon, and this one is the beta carbon. So here there is a OH group removal from the alpha carbon, that is a cleavage of CO bond is here takes place, and one H is removed from the beta carbon. So what it result? It result in the formation of alkene. How? Now it is left CH2 because one H is removed from here, CH2 double bond CH2. So what it result? It result in the formation of alkene, that is due to the removal of water, that is OH from the alpha carbon and H from the beta carbon, that result in the formation of alkene. You can check here between the alpha and beta carbon there is a formation of double bond. So that reaction is written directly here. So it is just like how you have done dehydrohalogenation, in which you have removed the halo group and the H. In the same way you are removing the OH and H in the case of alcohol. So this reaction can be explained in detail in this way. So removal of water, that is giving rise to an alkene, and the formation of a alkene when the ethanol undergoes dehydration in the presence of H2SO4 at 443 Kelvin. But when you look at the secondary and tertiary alcohol, the dehydration is taking place in the case of tertiary and secondary alcohol in the milder condition. That means when you look at here, the temperature 440 Kelvin, here 358 Kelvin. But in the case of primary alcohol, that is 443 Kelvin. So you can see that the temperature in the case of secondary is lesser than the primary. In the case of tertiary, it is again lesser. So why it happens? Why the secondary alcohols are undergoing dehydration in much milder condition? Because we have learned that the tertiary is more reactive than the secondary than the primary. That we have discussed here, the cleavage of CO bond is taking place, and the reactivity of depends upon the number of alkyl groups. In the case of tertiary alcohol, there are 3 number of alkyl groups, so this cleavage will be more easily takes place in compared to secondary and primary. That means tertiary is more reactive than the secondary, and the secondary is more reactive than the primary. So because of this reason, here also there is a cleavage of CO bond. That means in the case of dehydration, there is a cleavage of CO bond. So we can say that the secondary and tertiary alcohols undergo dehydration under milder condition. So you can check the formation of product here. So removal of OH and adjacent, that means if this is an alpha carbon, this carbon will be a beta. So removal of OH from the alpha carbon and H from the beta carbon. So there is a formation of alkene, and you can see a double bond formation between alpha and beta carbon. Similarly, when you talk about the tertiary, this is OH group, that is this carbon is alpha. So tell me which one is the beta here. There are 3 possibility. 1, 2, 3. 3 beta carbons are there, but all the beta carbons are similar. So whichever beta carbon you will choose it, you will be getting the same product. So here the product formed is alkene. That means OH from here, 1 H from here, it is removed. So we will be getting alkene. So the relative ease of dehydration of alcohol follows the order, that is tertiary is more reactive than secondary is more reactive than primary. Now let us discuss the mechanism of this reaction, which is quite important because in the exam usually there will be a question on mechanism. First step, it takes place in some step. So let us discuss the first step here. First step is the formation of protonated alcohol. What is protonated alcohol? When one H plus that is a proton, get added to alcohol, then it results in the formation of protonated alcohol. Look at here the reaction. That is alcohol plus H plus, that is a proton. Proton does not have any electron in order to make the bond. So here the lone pair which is present in oxygen, that is given to proton in order to make a bond. So you can see here now the bond formation takes place between the proton and with O. So here a positive charge develops on the oxygen. So this is called as protonated alcohol. This is called as protonated alcohol because a proton is added on alcohol, that results in the formation of protonated alcohol. That is the first step in the dehydration. Next step, formation of carbocation. It is the slowest step. Hence, it is a rate determining step of the reaction. Here there is a removal of water. You can see here there is a cleavage. Now the cleavage is taking place, that is a cleavage between the carbon and oxygen, that is a CO cleavage. It results in the formation of product, that is water is product, and it results in the formation of a carbocation. Look at here, now where is the positive charge? The positive charge is on this carbon. So what we call that is called as a carbocation. So in the second step, there is a formation of carbocation with the removal of water. Now in third step, what happened? There will be a deprotonation. That means removal, or we can say elimination of proton takes place. So this is the product which is formed in the second step, that is a carbocation. Now from here one H plus get removed. When this H plus get removed, the electron of this bond, that you can see this shift to this between this carbon, so that result in the formation of a double bond here. So that result in the formation of a double bond. So we can say that the product formed is an alkene. So look at the arrow marks carefully, how the displacement of electron takes place with the removal of H positive, that is the removal of proton takes place, and the electron will be shifted here, that result in the formation of double bond. So that is a formation of ethene. So what are the three steps which we have discussed here? That is first protonation, that means addition of proton, then removal of water, then removal of H plus. So how we can easily learn this mechanism? First, from an alcohol you have to add a proton, that result in the formation of protonated alcohol. In the second step you have to remove water, that give rise to carbocation, and the third step again you have to remove one proton, that result in the formation of alkene. So this is all about the dehydration of alcohol, which result in the formation of alkenes. This reaction is taking place in the presence of protic acid, therefore it is also called as acidic dehydration of alcohol. It's very important and its mechanism is also important. So thank you everyone.